one pager brings the whole pitch and all of hey guys, how you doing? Sorry. So I was doing here some speed reading, you know. I was doing some speed reading here, and but while I was waiting to start with you the conversation of the live class, and welcome everyone. Welcome to, I see many people here. I see Cheryl that is here saying hi. I see Matthias. I see Rushir. Hello, Pranav. Hello everyone, and welcome to a new live class. Today we have a very special subject because we are going to deal with a very, very new, very it's on the edge of ROS 2, and we are going to talk about a little bit about it, just an introduction. Okay, the subject is called HRIM, and is the hardware robot information interface, so we are going to see how it works. So in case that you would like to build controllers, or you would like to build products that want to be that want to share a common interface, so your programs for ROS 2 for those devices are going to be in a common interface using the same messages and the same services, the same parameters, so you can share information and you can create programs that can attack any type of instead of type, I would say any brand of controllers. For example, imagine that we have a servo motor that is made by branch A, and this branch A is following the HRIM standard. Then we have another one that is another servo motor from branch B, and it's also following the HRIM standard. Then if you create a program for controlling servo motors that are following HRIM standard, then your program can control both any type. So the robot that you are going to apply your program can be a robot built with brand A or brand B or any other brand that is following the same standard. Okay, so we are going to see how it works here with an example with the Mara robot. Okay, so how we are going to work on this? So the first thing is that we are going to use the ROS Development Studio as always. And as you know, this studio, what allows us is to program online on the web interface. And I'm going to share with you a notebook with instructions, with the Mara simulation already running, and we are going to open it and execute the simulation. You have to do the same steps as I am doing here on the class. So I expect that you are going to follow my steps by using the ROS Development Studio. And that's very cool because I see more than 20 people here connected today, and all of you can follow. You can do the same things as I am doing at the same time. And of course, remember that you have a chat there. And in case that you have any problem, you are not following, you lost a step, it doesn't work for you, whatever, you can put it there on the chat and I will be having a look and answering your questions. Yeah. Okay. Okay. Let me see if there is any problem here. I see Jonathan that is saying hi and nothing else. Yes, Cheryl, she is saying that she didn't receive an email. So she had to register. So we have implemented a system for registering for the live classes. But if you have already registered, you should receive a weekly newsletter that we are producing. And then on this newsletter, you have a link on to the live class of today. So the newsletter we usually issue at the beginning of Tuesday on Barcelona time. Okay, so at the beginning of Tuesday, then you should receive it. And inside that newsletter, you have the link in case that you are already registered for the live webinar. You have registered for previous ones. And if it doesn't happen to you, just send us an email at info@theconsortium.com and let us know your problem. Okay, so Cheryl, in case that you didn't receive the newsletter, you can tell us. Yeah. Okay, let's go, guys. We have some work to do. So what I'm going to do first is to share with you the whole ROSject. This is the ROSject, is the ROS project that contains the notebook, the simulations, the code that we are going to use today. So you can also open it and start working with me at the same time, okay? Yeah, let's go. Let's go. I'm ready. So what I'm going to do first is to share my screen with you so you can see what I am doing. Let me share here. Here. So here it is, my screen. So you can see here the ROS Development Studio. I have already opened the project that we are going to use today, the ROSject, but let me go to my list of ROSjects and get the address to share it with you. So this is my account on the ROS Development Studio, and today we are going to do this ROSject here. Is the ROS Developers Live Class 44. And yeah, and for that, I'm going to press this button and share the link with you. Remember that you can do this too. You can create your own ROSjects here on the ROS Development Studio and also share with your friends. And also you can search here for other ROSjects of other people. For example, we can search for Turtlebot and we'll see all the other ROSjects. Here it says 123rd. If you press here, you will get a list of all the ROSjects that do exist with Turtlebot. And then what is interesting here is that all those ROSjects, they do work in the same way as it works for the creators. For example, here there is an object detector Turtlebot ROSject that you can open it and see what it's about. It's about deep learning object detection calibration. It's made by this user. I don't know his name. But anyway, that's just showing you. Okay, so I'm going to my ROSject list. Then I'm going to share my ROSject for this class. What I did is to press this button and then get the link. Okay, so this link, and I already copied, and I'm going to paste this on the chat. So first, I'm going to shorten this because I need to shorten the link because it's very long. So I need to shorten because the chat of the chat copy here. The chat doesn't allow me to put a very long this. So a very long link. So let me paste it here. And there it is. So then what you need to do now that you are listening here is to press on the link that I have shared with you. So you press on that link, and then by pressing on that link, you will automatically got a copy of this ROSject with all the content, with all the notebooks, with all the simulations, with all the code, and it's going to work exactly the same way as it works for me. So what I'm doing here now on the screen, you should do the same things on your screen, on your computer. Remember that we are supporting at present Chrome or Firefox. So you should use one of those web browsers. Okay, so I presume that you have already opened it. Let me remove this so I cannot interfere with the share. It says, Pranav, it says my screen is stuck at initializing ROSDS page. Okay, Pranav, yeah, that's initializing the system, probably. So just go and click on the link. Okay, so click on the link and then you have to open the project, this ROSject that I have shown you. So how do we do? Then we press this icon here, run on ROSDS. So press on that icon, run on ROSDS, and then it's going to show this screen for you. And it's going to copy. Now it's going to open, sorry, the ROSject that I have shared with you. Okay, so I'm going to say no, because I want to start from fresh workspace. Great. So here we have the notebook that I have included into this ROSject. So here is the notebook that contains all the instructions and all the information about the things that we are going to do today. Okay, so let's go step by step. And this notebook, it's included into the notebook workspace that you can open. You can check it afterwards here. If you go to tools and then you open the IDE, you can see here several workspaces. The one of the notebook workspace is the notebook that contains here, that is the Jupyter notebook. Okay, so you can upload here. You can use the different options here to upload download the code. You can use the file to upload files, for example, images or other notebooks, whatever. Or you can use directly the Jupyter notebook here. Here is the Jupyter notebook. You can use it directly to create your own notebooks for your students, for your researchers, for your company, whatever. Okay, so let's go. So let me tell you that this is a collaboration between our company, the Construct and Acutronic Robotics. The Acutronic Robotics are the ones who have developed the hardware robot information model, the HRIM. Those are the developers. And also, they have created the Mara robot, that is this arm robot that we are going to use here in the simulation. Okay, but they have built the simulation and also the real robot. You can check the real robot and actually buy one of those and do these things that we are doing here today on the real robot if you want. So this is our collaboration, and let me explain you that what we are going to see here today is to understand what is HRIM, and then we are going to see an example of how an HRIM interface has been created for the Mara robot, and I will give you some guidelines about how to build your own HRIM for your own robot or your own device. Okay, so everything that I have provided here is called a ROSject. So you have here this notebook. If we go to the IDE here, we also have other things, like, for example, here in the ROS2 workspace, if you open it in the source, you can see that there are some messages generated for control, and also the Mara simulation here with all the plugins and all the information required for making Mara work. So this is what we call a ROSject, all this package. And as you have seen, you can share that information with anyone. So let me check just the chat just now very quickly, just in order to see if there is somebody that has any problem. I see no questions. So I assume that everything is working. So let's go again to the work. Then, yeah, you have here the content that we have included here. So what is HRIM? HRIM, okay, so it stands for hardware robot information model. Hardware robot information model. And then it's a way about creating an interface, a common interface for all robotics devices. So what is an interface? Okay, what I mean, and what I mean by a device. So what I mean by a device, I mean any part that can be inside a robot. It could be a sensor, for example, an IMU or a GPS, or, for example, a camera. Then this is a device, or could be an actuator, like, for example, a gripper, or could be a servo motor, for example, or I don't know, any type of actuator. So this is a device. And what is what I call a system interface? It means the way that your programs communicate with this device. So we have a problem of standards here. And this problem is that we cannot, the problem is that we need to have a standard system in order to make robotics to move forward faster. If we achieve to get some standards, then we will be able to build faster, because we will be able to use pieces from one vendor to another. There will be a lot of vendors selling parts for robots, and they will improve faster because there will be some competitors they will compete against each other. So that is necessary for robotics. We don't have a standard. And now we have a small standard that is ROS, okay? So ROS, it's okay. So it's acting as a standard in robotics. But the problem is, even if we buy, for example, a mic from a vendor that works on ROS, and another mic that from another vendor that works on ROS, even if we have both of them working on ROS, maybe the interface to every one of those is different, because every vendor has defined different messages or different services for each mic. So this vendor has defined this message that contains the raw data, and then the speech detected, and then the frequency analysis, I don't know. But this one only just goes and drives raw data of the mic detected, for example. Even if it's a ROS, even if they are using ROS messages, maybe the messages are completely different. So what happens that your programs, if you want to use a robot with this mic, has to be programmed in one way. If you want to use another mic, then it goes in a different way. So the HRIM, what it tries to do is to create a standard set of messages for any type of device that you can put into your robot. And what they do is that they classify any robotic module that you can have into a type. And then it defines the HRIM, let's call consortium or project, I don't know, they define which is the interface that you have to have for that type of device. Then which devices is defining? Everything is here included into the notebook, okay? So you can follow reading through the notebook if you want, instead of watching to me, yeah? So it defines the sensors. Sensor is a type of device that can be, and then inside sensors, there are subcategories, of course, for cameras, mice, IMUs, GPS, I don't know, sensors for pressure, sensors, I don't know, point cloud sensors, everything. So different categories, but it's a sensor. Then an actuator, a motor for a wheel, or a gripper, or I don't know, something that pushes, or anything like that. Then cognition modules. Cognition modules are modules that perform some kind of algorithm that solves a problem. For example, we can have a module that computes the SLAM algorithm, for example, or we can have a module that detects faces on an image of a camera and provides the positions directly. So these are cognition models. We also have communication models. Those are modules that allow the communication between different elements inside the robot. We have elements for power also, and for power means for batteries and for plugs to dongles or whatever. Then we have user interface modules. Those are modules that allow to interact the robot with the people, like for example, the touch screen, or I don't know, a set of lights that are reflecting the state of the robot and that you can act on them, etc. And then there is a final module that is defined by the standard HRIM that is called the composite. The composite, it's any other module that is created by a mixture of some of them. Okay, so what happens with HRIM is let's assume the HRIM is still in an early stage, okay? So they have defined this standard and they are working hard to be compliant with ISO certification. So they are working, this is work in the progress, okay? But it has been backed up by several institutions in Europe, for example, and for some companies, from the company, for example, Acutronic, that is the one that is developing and is an open standard. So any company can adapt that without having to pay anything. There is a way of making this standard. So the idea is that if you want to build a module, you want to create a company that works on ROS, then you can use the HRIM standard, and then your module will be HRIM certified. So it's HRIM certified. It means that it communicates with a common interface. So anybody can use your module and put it in these robots in order to substitute another one that is also HRIM, and nothing will happen. So I mean, you don't have to change your program if it was already working. So because it's an HRIM standardized certified device. Okay, so let me show you here. Let me change again to the screen of my computer. Here we have too many steps to change for the computer. Yeah, so here we have the HRIM interface for a rotary servomotor actuator. Okay, so we have imagine we have a piece that is an actuator that is a servomotor. And what is the interface that HRIM is defining for that servomotor? Well, so it's defining, if you want to build a rotary servomotor that wants to follow the HRIM protocol, the HRIM certification, then you have to provide the following topics on your motor. You have to provide, sorry, here there is a problem with this, the text, so let me put it in this format that you can see here. So you have to provide a topic that it's an ID that contains the component identification. Then another one that is about the status, another one for the power, then another one for specs communications, the state of the communication, then the model 3D. This is the URDF. No, sorry. This is for a 3D model. Yeah, the 3D model of the module. And then we have another one for the URDF. Some specifications of the device of this module. And then the goal in this case is for a servomotor is a position. So you have to provide the control in position, if it is in position, or in velocity, or in effort. It depends on the goal. Then those are the topics that you have to provide. And each one of those has to have a specific message type. This is also specified by the HRIM protocol. So the HRIM protocol, the HRIM certification, sorry, it defines the type of topics that you have to provide for a rotary servomotor, and also the type of messages that should go on those topics. Okay? We are going to see in a minute the messages. Okay. Finally, as a part of the interface for a rotary servomotor, you have to provide the following parameters. Okay. So it's the parameter origin that says where is the 0 point, and then the joint name. So what is the name for that joint in the whole structure? And that's it. So let's check, for example, all this information, how it works on the Mara robot. Because Mara robot, it's a robot that has been created also by the company that is Acutronic Robotics, that has defined the HRIM robot. So they want to, let's say, they want to lead with the example. So by being the first that use this interface and showing how it can be done, and that they are following it. So let's do it. Let's check it by using the Mara robot simulation, because we don't have the real Mara here. So let's try and let's launch the robot simulation. Okay. Before we are going to start to do that, let me check if there is any question here on the chat, in case that somebody has lost. Okay, Pabab says, I am stuck at the ROSject page. Mine is stuck in preparing project file. Yes, and Gianfranco says hi, and RSet says hi. Okay, Palab and Pranab, just wait. Okay, so just wait, because it's been a lot of people that has accessed the system at the same time on the free account, and then he had a certain amount of pre-ready machines for the people, and then we are more than 20 people now here working. So just wait a little bit, and but usually it takes a couple of minutes. So you should be ready in a couple of minutes. In case that it doesn't, please let me know on the chat. I will check in 1 minute. In 1 minute, no. After we do these actions here, I'm coming back to the chat and see if you have already started or not. And yeah, one thing before. So Pallav and Pranav, that you have the problem, just do a refresh of your browser and let me know. Also, check again that you are using either Chrome or Firefox. Okay, so let's go, people. So let's launch the Mara robot simulation. For that, let's open a shell. We need to do this manually at present because this is very new. Everything is very new. The HRIM is very new. It's just brand new, launched a few months ago. The Mara simulation is very new. ROS Crystal is very new. So everything is being launched in the last month. So still we are accommodating. So we have to do some work manually. So let's go. Let's do it. It's not bad. We are going to learn. So let's open on tools. Let's open a shell, a Linux shell. And then once we have that, let's launch those commands here. What we are doing here is to source the ROS2 crystal system and also the ROS2 workspace that we have in our user that contains the Mara simulation. And then we source also the Gazebo simulation. We set some models, paths, and plugins for Gazebo. And then finally, we launch the Gazebo simulator using this ROS factory that makes the Gazebo simulator work in ROS2 mode. Okay, so you can copy all of those, drag, drop, select everything there, Control-C, and then go to the shell and do Control-B. And launch all of them. Okay, so by launching this, you will get this message in green. You should get this message in green. It means it has started. Okay, so but where is the window of Gazebo? Hey, I don't see I haven't started, but where is the window? Okay, so bear in mind that this is a web tool. So we need to do some tricks in order to see the window. Very easy. Here you have the instructions on the notebook, okay? Go to Tools and then select Gazebo. So let's go to Tools and select Gazebo. And here we have the Gazebo simulation. Okay, so the commands that we have launched are just for an empty Gazebo simulation. We don't have anything here, just an empty wall. Okay, so here on the image, on the notebook, it says so. This is what you have to have. Okay, so far so good. Okay, let me check if on the chat everybody is following and the guys with a problem has been solved. Okay, Pallav says all set. Pallav says it's good to go. Very good. It remains Pranav. Okay, Pranav, let us know. We are very worried that you cannot follow. And Jonathan says all set. Also very good. Very good. So no problem. And the amount of people that is coming to the class is still increasing. And I'm so happy. So please come and tell to your friends and to come also. So everyone is welcome. Okay, and Pranav still says not working. Please, Pranav, do a refresh button there, a refresh again. And let me know the result. For the rest, let's continue. Let's launch the simulation. Here, now that we have an empty wall, we are going to spawn a Mara robot simulation. And for that, we need another web shell because this one is running Gazebo, so we cannot close it. And how do we do? You know already how. So you go to Tools and then open the shell, another shell, and you can put it here. Remember that all those shells that you have here, you can press this icon here that looks like a double window, a window on top of another window. If you press that button, then what it happens is that this shell will be converted into a tab of the browser. So you don't have to have that shell here running. You can close it, for example. You can close it and then launch the command here. And then you get a cleaner space. And also you can detach the tab, this tab you can detach and put in another window if you want. So you have all the comfortability as possible. Okay, anyway, so let me copy this command and you do the same. So it's the command that is going to spawn the Mara robot in the empty simulation. And let's go. So for that, I'm going to do it here on the, sorry, I'm not going to do it here. You can do it here. Well, I'm going to do it here. Yeah, anyway. So let me source. I'm launching everything here. And now we should see how the robot is spawning here. As you can see, it's spawning, it's been spawned. Yes. Okay, so here it is. The Mara robot. Yeah, and if I'm using the trackpad, so it's a little bit not very comfortable. Okay, so I hope that all of you have that. And now we are ready to start checking about the topics, if they follow or not follow the HRIM interface. Before we go there, let me check again on the chat if Pranab is working. Says Pranab, help mine struck at preparing project files. Okay, I don't understand that. It starts working problem with my university Wi-Fi. Okay. Okay, sorry Pranab for that. Then what I recommend you is that you just watch the video now and ask questions if something is not clear, but just watch a video and then you can reproduce this later, because the project, the ROSject that I have shared with you is for you forever, so you can use it later. Okay, so please keep me, let me keep moving forward for the rest of the class. And for the rest of the class, we are going to see what is working. So let's see if this robot is actually following the standards. And for that, we are going to see is the topics in ROS2, the topics that are published for that robot. And we are going to grep for a specific join number. Okay, so the join number is 3. So for that, again, we need another shell here. Open another shell. And let me put it here. And first you can do, if you want, you can do a ROS2 topic list. Remember, we studied about this command, ROS topic list, ROS2 topic list on the first live class of this month. And it's a basic command in ROS2. Okay, yeah, so what's happening here? Command not found. Okay, any answer? Somebody can tell me. You must know the answer about that. I'm watching on the chat. What is happening there? I need somebody to tell me what is happening here. So why I cannot launch the command? You must know that. Anybody knows the answer? Sources. Very good, David. We have to do the source, exactly. Remember, usually you need to source set up bash. Exactly, Jonathan, correct. That's also correct. Then remember that you can put this source into your bash RC file. So if you want, you can do it. So anytime that you open a new shell, you will get this source done. Now we are going to do it manually. So how is it? It's source opt ROS crystal setup.bash. So that is the bash that is setting this terminal to work to recognize all the packages of ROS2 crystal. Okay, so now you can launch the command ROS2 topic list, and then you will get it, the list of all the topics. There it is. And as you can see, we have several motors, of course, because this robot has many motors there. And what we are going to do is just to concentrate on the number 3 that we have here, because too many things. So what you can do is to do a grep. A grep is a command in Linux that filters by a certain string. So you can let's filter by 0003. Okay, so there we have. Oh, okay. So I should have filter 003 slash in order to prevent the 32 also. Now I have it. Only the topics that are the ones for related to the join number 003. And this is a rotary servo motor that is following the HRIM protocol, the HRIM standard or HRIM interface for rotary servo motors. And as you can see here on the list of topics that I completed here, so we have the ID, the status, the power, the specs com, state com, module 3D, module URDF, specs, and goal also. Okay, so you got it. Then what else? So let me know if that works for you. And we are going to move into the messages also. And okay, I would say something about the parameters also. But let me check the chat if you have any question or. Okay, Gianfranco says setup. Also correct, Gianfranco. And Miguel Cordero, of course, source is the. Yeah, okay, yeah, I understand. Yes, correct. Okay, no problems up to here. Great. Let's continue. Then another thing that has to be defined are the parameters. Remember that I have said that you need to have, for this specific servo motor, you have to define those topics and those parameters. Okay. Then here we have checked that it contains the topics, and then about the parameters, you should do here, yeah, ROS2 param list. Instead of ROS topic list, let's check for the parameters. And the thing is that in this version that we have here, if you execute this command, then it doesn't show actually the topics that should have there. They should appear here beneath those 2 dots, but they don't show. And this is my mistake, because that was detected on the weekend, and I received the update of the simulation. So that's a mistake on the simulation. Okay, so the simulation is actually not setting those parameters when it is launched, and that's why they don't show here. And this is a mistake that I detected on the weekend, but unfortunately, I didn't have the time to correct this. The people from Acutronic, they have corrected it and provide me already the solution, but I didn't have the time to put it into the ROSject that was already made since the weekend. And that is my mistake. I apologize for you, but I mean, the concept is the important thing, so don't pay too much attention to that. Remember that this ROSject that you have here is Git synchronized with the Mara simulation repo. So what does it mean? It means that if you go to the Mara directory here, let me show you. You go to Tools and open the IDE here. So you have here the ROS2 workspace, source directory, and then you have this Mara directory. This Mara directory is the one that contains all the packages related to the simulation. if you go there using a shell, let's go using this shell. So I have to go cd to ROS2, the score workspace, then source, and then Mara. If I do an ll command, you will see that this directory is synchronized with Git. So it's directly synchronized with the Git of the original Git, the one from Acutronic. This is an open project, an open source simulation, open source Git. So it's here, and then at any point in time, you can update it. Actually, you can do a Git pull in order to get all the changes that the people from Acutronic they have done for modifying this parameter problem. Okay, so they have done it very well done, but the problem is I didn't have the time to update it. So to do this pull, because I did this pull and then it got some problems here. It's not a big deal, but they have to do some changes here. So because we did some modification, so now we have to merge the content that we have here with the modifications made by the people of Acutronic, and then recompile the Mara project. Okay, so I didn't have the time because when I tried to recompile, I have some problems and I needed to solve them. So this is homework for you. Okay, if you want to get the parameters that should look here, then here is your homework. Do the git pull in your directory of Mara, then solve the problems here, git problems, and then recompile. And when you recompile, you will have all the problems, but you can, I'm sure that you are smart enough to solve those problems in the compilation problem. Okay? You know how to compile in ROS2, okay? If you don't, just go to the first live class of this month and you will learn how to compile a package using Colcon, okay? Colcon, yeah. Okay, I'm not going to tell you more. So you have to do, this is your homework. And of course, if you get stuck, just put the questions beneath the video, this video, and then I will answer them, okay? But try, please try. So this is a very good word for learning ROS2. Okay, so we got this interface that is based on the topics that had to be published, the parameters that need to be published, published or set, the ROS params that need to be set, also the services that need to be created. But in this case, for the servo, there is no services defined by the HRIM protocol. Okay, so up to here, it's okay. And then the next thing that needs to be defined for a interface is the messages that should go through those topics, of course, because even if I define my topic, but I define a different type of message here, then what is the point? So I have the topic, but the content of the message, the structure of the message is different. So those have been defined already by the HRIM. And where are they located? Well, they are located in the HRIM code. So in the HRIM repo, the HRIM repo is the one that defines everything. So you can use the HRIM code, the HRIM repo, to generate the messages and the packages that define the messages for the topics that you have to create for your device. So I think that it's going to be better if we see the code actually, and then I show you how it works. So let's go and let's clone directly here the HRIM repo inside here, inside our ROSject. So for that, you need to go to ROS2 workspace /source. So let me get one up on top here. Here you have the control message package generated and Mara. If you use the IDE here, you can see, okay, tools IDE. You can see that we are now on the shell. We are on this level here. Okay, so now let's clone there. Let's clone the HRIM repo that contains all the code for generating the packages of the messages for a certain device, for all the device actually. So let's do the git clone that you have here. This is the command that will clone the HRIM repo. So let's do it. And then, yeah, it's quite quick. And then if you go to the IDE, now you see that there is a new directory called HRIM. And inside here, you have a directory that is called models. Okay, so this is starting to look like what I explained at the beginning. As you can see, the models, there is a model folder for each type of device that you can define in the HRIM standard. Okay, for example, we have one for the actuator. And what is happening here? Okay, so inside those folders, what is happening is that we have the different type of actuators that have been defined up to now by the HRIM standard. And here inside the servo is where we have the definition of the messages that a servo has to provide. Okay, so in order, the HRIM is trying to provide a standard for interfaces for devices, okay? And how does it do? By specifying the topics that your device has to set, the parameters, the services, and also the type of messages that you have to put inside those topics. And how do you define the structure of those messages? Is through XML files here that you have. So I'm not going to go into detail what is the format there, because you have here a link. I have put a link here for the full documentation, so you can search here and understand the format of those XML files. But basically, what you are indicating here, you can open, okay? You can open this file, double click on the IDE, and let me show here. So this is an example, and this includes other files that are inside the topics folder for acceleration data, temperature, whatever. So you can follow. This is an XML format, and this format is explained here in the documentation of this page. You follow this link, you will reach the point where to define how it is defined for each one of the type of devices. Okay. So I'm not going to go into the details of that because it's just an introduction, this. But the important thing that you must understand is, okay, so here we are defining in an XML the message that has to be sent through a topic, okay? But you may think, hey, wait a second. So why should I define the message using an XML? Why I don't use an MSG file like we do always in ROS? So in order to define a ROS message, I just use an MSG. I don't use an XML file. And that would be a very good question. But here is where the power of HRIM comes, the superpower. So it's a lot better, the better idea. So by defining the message in this format, what happens is that you can generate the packages of the messages for any robotics framework that you want to program for. Yeah, I understand. So yeah, that's complicated. So what I mean by robotic framework, well, by a robotic framework, I mean ROS. But actually here we have two different ROS. We have ROS 1 and ROS 2, okay? So but then also there could be other frameworks. There exists, for example, ROS framework or YARP framework, or I'm sure that Google is going to launch his own framework. So there will be Google framework for robotics. So imagine here that just by defining the message in an XML once, then you can compile this message for a certain robotics framework, and then it will generate the packages for that specific framework. Okay, so that is why the messages are defined in XML. XML is like a framework agnostic way of defining the messages. The topic, here it says position, the type of information that goes on that, the type of information that goes on that topic, and then the unit, and then a description. So this is a framework agnostic. So by defining here, the HRIM is very clever, because it says, okay, I don't care which one is the framework that you as a programmer are going to use. In any of those, you are going to use the same definition in an XML. So at present, HRIM is only able to compile for ROS2, okay? Don't get mistaken. So at present, it only works for ROS2, but, well, it's a thing. So it's prepared for compiling for other ones. And how do you compile this? So you compile by coming here to a shell and creating, so issuing this command, Python 3 HRIM by generate, and then you indicate the type of actuator or device. In this case, is an actuator for the servo motor, but you can specify any of them. And then it will generate the packages for ROS2. And there are options for generating for other frameworks. But in this case, let's issue that. So if you issue this command, Python 3 generate model servo motor. Okay, remember that in order to do that, you have to be on the HRIM directory first. Okay? Because it's there where the HRIM Python, this HRIM binary, or Python binary, is there, is located. So let's go to inside the cd HRIM, and then issue this command. It's Python 3, it works on Python 3, HRIM.py, generate, and then this path to the XML that is defining the type of device that you want to have. Oh, I'm going to copy and paste because it's, oh, damn it. Okay, so I did it badly. So HRIM, generate. So now it has generated the packages for the messages for the servo for a ROS2 in a framework, robotics framework. And if we go to the IDE, we can see that it has been generated. So here, this new, inside HRIM, there is a new directory called generated. And here you have all the packages that have been created that are required, that you as a programmer have to use in order to create a program that interfaces to any rotary servo that follows the HRIM. So here we have, for example, the HRIM actuator rotary servo messages. And then if you go inside, you are going to see the message folder and then the typical MSG files that ROS uses, of course. So if I open it, then I will see the typical structure of a ROS message. Okay. So before we are going to finish here, and before we finish, let me tell you that you can issue this command also, Python 3 HRIM list models, in order to get a list of all the current available models that do exist in the HRIM implementation. So if we go here and do on the shell, and then issue the command Python 3 HRIM list models, then it's going to tell us, okay, you can create at present with HRIM an actuator that is an electric motor, or you can create a gripper or a servo or an arm that's a composite. It's a conveyor, a mobile base, a battery, a 3D camera, encoder, different types. So you can see here all what is at present supported already done. So I'm in contact with the guys of the HRIM. It's Alexander and Alejandro, actually, and Victor, the main leaders of this. And so they expressed me that they will be very, very interested to see if anybody wants to contribute for creating the models for other devices that are not included here. So they will be very happy if you can contribute, because it's an open source project and it's for everyone. So it's not their standard. It's a standard that they are putting to the public in order to make it available for everyone. So have a look. Then I think I'm going to finish here because it's too much information. I have an extra step, but I'm going to finish here because it's too much. And what I would like to ask you is that if you liked the class, please to give us a like, a thumbs up, and subscribe to our channel and press the bell, because we are publishing new videos every day about ROS, ROS2, how to do many things in ROS projects with the ROS that you can do off the shelf. And so this, if you give us a like and a thumbs up, then this will support our work. And just to let you know that in case that you would like to learn a lot more about ROS2, we have an online course here. I put here the link in the Robot Ignite Academy, and this course is teaching you everything of ROS2, from creating of packages, service servers, managing how to compile, how to use the ROS1 bridge, and topics and publishers, debugging, and well, and everything using C++ and the launch system using Python. And you are going to program in different simulated robots, these ones here. Just have a look, okay? So just in case that's in there. And finally, so I have included here a coupon that provides you a discount for that course. And finally, let me tell you that here, in case that you would like to pre-order one of the Mara robots because you are interested, I think they have a very good price. Here you have the link, and you can practice everything on the simulation and then transfer to the real robot from here, from the ROS Development Studio itself. And that's all from me, from my side. Let me see if you have any question on the chat before we start.